anchor a 500-foot vertical marvel, we begin by taming the raw earth, carving a massive foundation directly into the bedrock.
Every strike against this subterranean rock tests the limits of our heaviest machinery.
High-torque rotary drills pierce 60 feet down, preparing the subterranean perimeter to fight back against immense lateral earth pressures. This specialized polymer slurry acts as a liquid shield, preventing the loose, ancient soil layers from collapsing inward.
Heavy lift crews fight high winds to guide massive steel cages into the earth, forming the internal skeleton of the retaining piles.
Continuous concrete placement from the bottom up ensures zero air pockets within the subterranean supports.
Millions of cubic feet of displaced geology must be cleared around the clock to keep the project on its aggressive timeline. Mechanized shotcrete stabilization locks the exposed earth in place, creating an impenetrable barrier against structural collapse. Progress grinds to a halt as our teams strike an unmapped vein of ultra-dense granite, demanding sheer mechanical brutality to break through. Pushing hydraulic pressures to their absolute maximum, we shatter the subterranean obstruction inch by grueling inch.
High-tension rock anchors are driven deep into the surrounding geology, tying the site permanently to the planet's crust. Pre-stressing each anchor ensures the subterranean walls will never bow under the weight of the future skyscraper.
Striking an underground aquifer threatens to flood the site, turning our foundation zone into a battle against rising water.
Industrial-grade sub-pumps run continuously, exhausting millions of gallons of water to keep the bedrock dry. With the subterranean perimeter locked down, the final floor of the excavation is scraped clean to the primordial bedrock. Precision digital surveying guarantees that the structural footprint is accurate to within a fraction of a millimeter. Logistical synchronization brings hundreds of tons of high-strength steel to the site as the project transitions out of the dirt.
Extreme heat prepares the primary steel elements for seamless integration into the building's deepest anchor points. The lifelines of the project, two colossal tower cranes, are erected to dominate the airspace above the site.
Every anchor bolt of the tower cranes must withstand thousands of foot-pounds of overturning force during heavy lifts. A thick, vibrated gravel subbase is laid down to distribute the unimaginable weight of the coming structure evenly. High-frequency mechanical vibration eliminates voids, sealing the earth beneath an unbreakable floor.
An impermeable synthetic barrier is laid down to permanently isolate the skyscraper's foundation from subterranean moisture. Sealing these joints with extreme heat ensures that not a single drop of groundwater will ever breach the lower levels. The battle against the earth is won, the stage is perfectly set for the most critical phase of construction, the concrete monolith. We now lay the dense iron skeleton of the skyscraper's foundation mat, a crucial element to bear the weight of a 500-foot waterfall.
Tens of thousands of individual steel intersections are bound tight, creating an unbreakable matrix of reinforced iron.
This dense steel weave will provide the vital tensile strength required to counter seismic shifts and extreme wind loads. High-capacity hydraulic cutting tools customize the reinforcement layout on the fly to accommodate massive water intake channels. Industrial steel formwork walls are locked into position to contain the immense pressure of the largest concrete pour in the region's history.
Structural bracing must hold true against hundreds of tons of liquid concrete pushing outward.
The critical moment arrives. A non-stop, 48-hour continuous pour begins to cast the monolithic foundation slab.
Specially formulated low-heat concrete mixes are used to prevent internal thermal cracking during the massive curing process.
High-pressure hydraulic pumps force thousands of cubic yards of concrete through the air and directly into the heart of the foundation.
Intense mechanical vibration forces the thick liquid stone into every microscopic crevice of the dense steel matrix. As day breaks, the relentless pour continues without a single interruption to prevent weak seams from forming. Precision finishing machines level the surface, ensuring a perfectly balanced floor for the skyscraper's vertical core. Controlled hydration blankets maintain the perfect moisture level, allowing the concrete to achieve maximum design strength. Monitoring the core temperature is vital. Excessive internal heat could compromise the structural integrity of our entire base.
With the formwork removed, the cured monolith stands ready, an unyielding anchor capable of carrying millions of tons.
Core samples are rigorously tested under extreme compression to verify that our foundation exceeds all safety factors. We now lay the tracks for the self-climbing formwork, the mechanical engine that will drive the building's spine skyward. These powerful hydraulic pistons will lift entire floors of heavy steel and forming panels without the aid of cranes.
At the base of the tower, construction begins on the massive subterranean cistern that will hold millions of gallons of cascading water.
Every weld on the main water intake must be completely flawless to survive decades of continuous high-velocity water movement. Giant, high-efficiency turbine pumps are anchored into position, ready to defy gravity and lift rivers of water 500 feet high.
Special heavy-duty rubber isolators are installed to prevent the immense mechanical vibrations of the pumps from shaking the building's frame.
The lower levels are sealed, providing a rock-solid platform from which the main skyscraper can now begin its vertical journey. Heavy-gauge steel columns are locked down, ready to transfer the immense loads of the upper floors straight to bedrock. The invisible engineering is complete. Now, the artificial Waterfall Skyscraper is ready to rise into the sky. The skyscraper's spine breaks into the skyline, driven upward by the relentless cycle of our self-climbing hydraulic forms. With a powerful hydraulic push, the building climbs another story, a highly synchronized dance of steel and pressure. High-strength structural steel framing radiates outward from the concrete core, defining the tower's unique aerodynamic shape.
Working hundreds of feet in the air, ironworkers brave the elements to lock the building's skeleton together. The tower's architectural identity emerges as the deep, central waterfall track is seamlessly carved into the building's face. The waterfall channel is lined with ultra-dense, composite panels engineered to withstand a constant, high-velocity aquatic assault.
Specialized superplasticized concrete is pumped vertically under extreme pressure, defying gravity to reach the upper decks.
Every pipe connection must withstand thousands of pounds of pressure as we push liquid stone higher than ever before.
As the tower grows, the cranes must lift themselves, anchoring into the newly cured concrete floors below them.
High-penetration welding ensures that the vertical structural joints possess a higher strength than the steel itself.
The outer glass skin follows closely behind the structural steel, sealing the lower levels from the wind and weather.
High-performance acoustic and thermal glass panels are locked down to isolate tenants from the roar of the future waterfall.
The skyscraper's internal arteries, massive high-pressure water risers, are installed to carry the river to the summit.
The robotic orbital welding guarantees completely flawless, leak-proof joins along the entire 500-foot vertical water line. At extreme heights, fierce wind loads present a constant hazard, forcing crews to secure every piece of equipment with high-tensile steel cables.
Real-time meteorological tracking tells us when the cranes must halt operations to protect our ironworkers in the sky.
Advanced water hammer mitigation systems are integrated to manage the incredible kinetic energy of the moving fluid. Every valve and fitting is torqued to strict aeronautical standards to ensure absolute control over the high-pressure system.
The concrete core reaches its final destination, topping out at a breathtaking 500 feet above the city streets.
The final piece of structural steel is secured, marking the completion of the tower's skeleton.
Work shifts to the crown of the tower, where the complex, aerodynamic waterfall distribution crest is carefully constructed.
Micro-adjustable steel weir plates ensure the water releases in a perfectly uniform, unbroken glass-like sheet.
The exterior facade completion transforms the raw concrete and steel frame into a sleek, reflective architectural icon. Precision laser profiling verifies that the waterfall track is mathematically perfect, preventing unwanted wind drift spray. The vertical channel is completely clear, structurally sound, and ready to unleash a torrent of water down the building's face. The heavy industrial tools that birthed the tower are slowly stripped away as the project enters its final transformation. Demobilizing heavy equipment from a 500-foot roof demands absolute focus and precision from our veteran operators. The ground level is transformed into a lush, organic park designed to receive the immense kinetic splash of the waterfall. Specialized aeration jets are calibrated to break the surface tension of the falling water, eliminating catastrophic splashing. With the heavy machinery gone, the pristine, organic architecture of the skyscraper is finally allowed to shine alone.
The moment of truth arrives as the primary electrical grids are energized to spin up the massive water turbines.
Thousands of horsepower engage instantly, drawing millions of gallons of water into the primary vertical risers. Pressure spikes inside the heavy steel arteries as water is propelled upward at a staggering velocity. Gravity meets human engineering as a massive river breaks over the edge of the skyscraper for the very first time.
The distribution crest performs flawlessly, casting an elegant, controlled aquatic veil over the building's face. Dropping at terminal velocity, the water creates a mesmerizing, ever-changing pattern against the structural glass background.
Our advanced acoustic dampening completely neutralizes the acoustic fury of the waterfall for the occupants inside.
The lower energy dissipation basin captures the immense force of the impact safely, recycling every single drop of water.
A fully closed-loop sustainable filtration system guarantees zero water waste, reusing the same river indefinitely.
Dynamic architectural lighting illuminates the falling river, transforming the structural marvel into a brilliant column of liquid light. Fully programmable illumination syncs with the water movement, creating an unprecedented public visual spectacle.
Human ambition and natural wonder fuse seamlessly into a single, breathtaking piece of structural engineering.
Every micro-engineered detail, from bedrock to sky, functions in perfect harmony to sustain this artificial cataract. Standing 500 feet tall, this building completely redefines what is possible when architecture dares to defy nature.
Built on a foundation of unyielding determination, this monument stands as a testament to human ingenuity.
From the dark depths of excavation to a shining crown in the heavens, the journey of this engineering masterpiece is complete. The artificial Waterfall Skyscraper now reasserts its dominant, permanent place at the absolute pinnacle of the city's identity. A living, breathing fusion of structural mechanics and fluid dynamics that will inspire generations to come. A 500-foot wonder of the modern world, built to endure, designed to awe, and engineered to conquer the impossible. This is the future of architecture, where humanity carves its dreams directly into the sky.